In this video, I wanted to explain how to find the work exerted on an object. Suppose that you apply a 4 Newton horizontal force on an object, causing it to travel 3 meters. We can calculate the amount of work done on this object by multiplying the applied force by the displacement. Using this formula, we calculate the work to be equal to 12 Newton meters. This represents an amount of energy, and it's usually expressed in joules. What if instead the same force was applied at a 30-degree angle? The amount of work done on the object will no longer be equal to 12 joules. Since this is the case, we'll need to rewrite our formula for calculating work. In the first scenario, work was equal to force times displacement, but that's only because the force was acting in the same direction as the displacement. We can be more specific by saying that work is equal to the force times the displacement multiplied by the cosine of the angle between them. Using this formula, we find that the work is equal to approximately 10.4 joules. This formula allows us to multiply the horizontal component of the force by the displacement. If the angle between them is 0, the cosine of the angle will be equal to 1, which means that the entire force is contributing to the work done. This is the case when the force is acting in the same direction as the displacement, such as in the first example. If the angle between them is 90 degrees, cosine of the angle will be equal to 0, which means that the entire force isn't contributing to any work. For example, if the force was acting in the vertical direction and the only displacement was still in the horizontal direction, the amount of work done on the object would be 0. For this reason, we know that both the force due to gravity and the normal force don't contribute to any work on the object. However, if a vertical force was applied on the object and the object was displaced in the vertical direction, there would be work done on the object. Let's now go back to that first example where a horizontal force of 4 newtons is applied to the object. What if a 1 Newton friction force also acts on the object? We can see that the angle between the friction force and the displacement is equal to 180 degrees. Using the formula for work, we're able to find that the friction force does negative 3 joules of work on the object. This value is negative because the force acts in the opposite direction of the displacement. By adding this negative value to the 12 joules of work that we found previously, we're able to find that the net work on the object is equal to 9 joules. Alternatively, we could have gotten this answer by finding the net force on the object and then calculating the work done by that force. I hope that this video was helpful and that it gave you an understanding of what work really is. In my next video, I'll go over kinetic and potential energy and how they relate to work. If this video was helpful, please give it a like and consider subscribing to the channel. If you have any questions about this concept, feel free to ask them below. Thanks for watching.